you expect to be there and therefore what you perceive. So it's good news having this system, I think, but it's also potentially bad news, the danger of inflexibility. We see what we expect to see. And this is where I think the importance of prediction error as a signal for change, a signal that our inferences are wrong, becomes important. This has been beautifully described by Wolfram Schultz, Tony Dickinson. I would recommend to anyone, even though it's getting a bit dated now, their 2000 review, an annual review of neuroscience. Learning is maximized in the setting of unpredictable events. Prediction error relates to the very essence of learning. Prediction error in the context of associative learning has been around for, well, 40-odd years now. And it's been formulated in a very famous equation of Rescorla and Wagner, which essentially says that the amount that we update our inferences on a given trial is equal to, well, we won't go into this, but it's proportional to the expression in brackets, which is what we're seeing on that trial minus what we expected to see. In other words, the mismatch between what we're seeing now or getting now and what we expected, the prediction error. And this is demonstrated really beautifully in the famous blocking paradigm, which was first described by Kamin in rats in, I think, 1969. This is a more up-to-date version done on monkeys. And I'll just take you through this because it illustrates the importance of prediction error in what you learn and what you infer about stimuli in your environment. So the idea here is that the monkey sees a stimulus and that's followed by a reward. And so when it sees the stimulus, it learns to engage in anticipatory licking behavior, which is signified by these black bars. Then it gets the reward and then it licks. There's another stimulus it learns that doesn't predict the reward. So essentially, there's a reward predicted and no reward predicted. We then take these stimuli forward and pair them up with another novel stimulus. And in this case, the reward will be strongly predicted because of the presence of this stimulus, which has already been learnt. But here, the reward won't be predicted because this one doesn't predict reward. So the difference at these points is that reward is not predicted. So what essentially is happening is that there's a reward that is predicted and a reward that is not predicted, and that should lead to a prediction error and therefore error-dependent learning that is applied to the novel stimulus. And that leads to a change when you subsequently present it on its own. Because as you see, if you take this stimulus forward, the monkey is not interested. There's been no prediction error. It hasn't learnt anything about that. So it's one solitary lick on one of the trials. But when it sees this, where there has been a prediction error, it licks like crazy. Prediction error is critical to learning, to association formation. What are the attributes of prediction error? Well, a mismatch between current and prior input expectations is key. It's a signal that our current model of the world is wrong, and it's a drive to updating that, to learning. It's also a drive to attentional allocation and to motivation towards specific things in the world. And it's also a marker for distinguishing internally from externally generated phenomena, I think. I mean, I'm not alone in thinking this, but something that we do ourselves produces sensory consequences, produces changes in the world that is predictable compared to something that happens from the outside. So what would happen if prediction error was wrong, if it was erroneous, consistent, independent of our actions? Well, things would seem different. The world would not fit together. Uncertainty levels would be raised. New associations would be learned, new meanings would be sought, even when those are not appropriate to learn. We wouldn't get things like blocking, for example. Things would feel novel, they would feel salient, they'd feel important, they would grab our attention. The distinction between internally and externally generated phenomena might be blurred. If I do something that produces a sensory consequence that I wasn't expecting, perhaps it wouldn't feel like me doing it. Would it be an anxiogenic world? An unpredictable world would raise anxiety. And here's another study from here by Katrina Carlson and others, in which they showed that if you present painful stimuli, that's these high here, in the context, these are two separate experiments, one was done in MRI, but if you present them either in association that's correlated with a predictive stimulus or they're presented in a rhythmic way that you can predict, the unpleasantness of those stimuli in various levels of anxiety, negative valence and intensity is increased by unpredictability. Unpredictability makes the world more anxiogenic and it makes painful things more painful, more anxiety-provoking. What do we see in people at the early stages of psychosis? Is the phenomenology like one would predict from this disruption that I've suggested? These are some very nice quotes from some beautiful papers written in the 1960s by Chapman and McGee, who actually just sat down with patients at early stage of their psychosis and asked them what it was like. Didn't try to fit these into particular psychopathology or diagnosis or anything. They simply asked them, what is your experience of the world? And people regularly report, I've taken some selective quotes, but these are not that selective, these are regular. Colours seem to be brighter, everything brighter, louder, noisier. Seeing things in a strange way, things become flat, you lose depth perspective. As if someone had turned up the volume, background noises would seem louder. Norma MacDonald, who suffered from schizophrenia, describes this very graphically. It was as if parts of my mind awoke. I became interested in a wide assortment of people, events, places and ideas which normally would make no impression on me. The walk of a stranger, every face in the window of a passing streetcar would seem important to her. People change the way they form associations. This again is from Chapman and McGee. I've got too many thoughts. You might think about that ashtray and just think, oh yes, that's for putting cigarettes in. But I would think of it and then think of a dozen different things connected with it. I try to read, but everything I read starts me thinking in 10 different directions at once. Peter Chadwick, a psychologist who suffered from a psychotic illness and has written, again, very poignantly about it in some of the psychiatric literature, describes having to make any sense out of what he called uncanny coincidences. I did it by radically changing my conception of reality. Now, this is not a new idea, that association formation is abnormal. I think what the privilege we have nowadays is that we have a developed cognitive neuroscience of associative learning and prediction error. But for a long time, people have been trying to explain the phenomenology of psychiatry in these terms. Bloiler talked about fragments of ideas connected in an illogical way. Schneider, meaningful connections are created between just simply coincident external impressions or perceptions and thoughts. Pavlov, actually, not many people realize, was very interested in looking at schizophrenia from a model of conditioning, or in terms of abnormal conditioning. I won't dwell on these things. Emmerich, Einhorn and Hogarth, Gray and Hemsley have done some beautiful work talking about comparator, which brings together the current state of the organism's perceptual world with a predictive state. And again, more recently, Kapoor has written a celebrated paper talking about the dopamine system, which is associated with associative learning and error-dependent learning, and incentive salience. So delusions arise out of abnormal allocation, leading to erroneous associations. I'm just rushing through that to give you, really to exculpate myself from the accusation that I'm trying to pretend I've thought of all of this. This really is a long thread going through psychiatry. But how do we test it? How can we actually embed this broad, slightly ill-formed idea in some experimental hypotheses? And I think here functional imaging has been useful. I don't think functional imaging is always useful by any means. I think it's actually used very beautifully in this department, and I'm a big fan of the work here. I think there's some psychiatry functional imaging that really fails to actually test particular hypotheses. So I'm not an absolute advocate of functional imaging, I must say, but I think it can be useful here because we can take people and we can either increase prediction error or decrease it by fulfilling their expectancies in the context of imaging. And we can identify brain regions that code that difference. Which brain regions are more interested here than they are here? We can do that imaging in healthy controls, just to outline the system. We can do it in patients with psychosis. We can do it in healthy controls in whom we've tried to engender a psychotic state. And I'm very interested in the ketamine model of schizophrenia, which I'm not going to go into because of time constraints, but I think it's potentially very useful in modeling these particular ideas. And the other thing we can do is relate the changes that we see here to the actual symptoms that they get or to the cognitive changes. And one thing we've become very interested in doing is actually scanning our healthy controls under normal circumstances and then giving them ketamine at a later date and seeing how vulnerable they are to different symptoms. So this is a way of really trying to hold on to fixed points and identify the system, see how it behaves across different individuals, and then see how they respond to a drug challenge. The initial work I've done was on causal associative learning. A lot of this was done with Phil Corlett, my former PhD student who's now in Yale. And we've done some simple associative learning across a series of tasks, and I'll just briefly give you an overview of those. So this started with some work we did showing that if you get people to play a simple game in the scanner, this is just healthy controls